It's really difficult to say because it does change so quickly. I think that you will get to the point, all of the changes that we're seeing are essentially increasing the resolution of what we can see. Where we used to use 1,000 markers to try and map a genome, today we're using tens of thousands, hundreds of thousands. In a lot of cases now, with the sequencing technology being so cheap, companies are simply resequencing in their entirety the lines that they're most interested in. And that will continue to happen because now you can resequence things for such little money. The other thing that will happen on the application end is that the screening, the genetic screening of plants will be much higher throughput and much less expensive. Already we're seeing companies screening millions and millions of plants a year for traits that they want. If you look at some of the large companies like Monsanto and Pioneer have both developed these seed chipping technologies. So now they can shave off a little piece of the seed and screen it for multiple traits without ever putting it in the ground. So they make the decision before the seed's even planted as to whether it's going forward or not in their breeding program. Those types of things will continue to evolve that way. So we'll see higher resolution work being done. That'll open up the door to much more complex traits, as we discussed earlier. You'll see the applications of these technologies at the field level changing dramatically, so that you won't need the same level of complex equipment going on. I presume that at some point in the future you're going to be able to do more and more of this analysis closer to the field, and so on and so forth. So it's a little difficult to say for sure, but I think all of these things are possible.